A random sample of 40 students has a mean annual earning of $3,120. Assume that the population standard deviation excuse me, is $677. Construct a 90% confidence interval. I should say construct and interpret a 90% confidence interval for the population mean mu. Okay, so that's the problem we are given. And in this problem, note that we are given the population standard deviation. Look at that here. The population standard deviation is given to us, and that population standard deviation is $677. And I told you in the previous videos and an example that when we know the population standard deviation, we always use a z distribution, right? So in order to solve this problem, I will adopt step-by-step method. So first of all, we are going to have a step 1. So what we do in step 1, we check the basic condition. We check whether the basic conditions are met or not. Basic conditions. Number 1, what were those basic conditions? Just recall. Number 1, you have to have a random sample. You have to have a random sample. Number 2, let me write that and then we'll talk about that. And number 2, sigma known. The population standard deviation must be known. And number 3, either n is greater than or equal to 30 or the population is normally distributed. Or the population is normally distributed. These are the basic requirements that needs to be met in order for us to construct a confidence interval. So let's check these conditions one by one, whether these conditions are met or not. Number one, random sample. Look at that, the first line, a random sample of 40 students. Look at that clearly. It's a random sample. So the first condition is met. Sigma known. Look at that. The population standard deviation is known to us. We know that. It's a 677. Second condition is also met. Either the sample size is greater than 30 or population is normally distributed. Look at the sample size, n. Our n is the sample size, which is 40, and 40 is definitely greater than 30. So we don't need this condition for this particular problem. It looks like that we have a sufficiently large sample size. I told you in my earlier videos that this 30 is a kind of a magic number, right? So statisticians all agree that if a sample size happens to be more than 30, we will consider it as a sufficiently large sample size. So n is greater than 30, so we are good with this condition. So all the three conditions are met, so we can say our first step is satisfied. Let's go to the second step. What is the step 2? What we do in step number 2? In step number 2, we decide confidence level and we choose critical value, corresponding critical value. That's what we do in this step. Okay, so first decide what is the confidence level. Look at that. We have to construct a 90% confidence level. Look at that. So our confidence level is equal to 90%. That's clear. And I told you in my earlier video, if the confidence level is 90%, then the critical value, which we represent by z star is always 1.645. If you don't know what I'm talking about, look at my earlier video that corresponding to a certain confidence level, 90%, 95%, 99%, what are the choices for the critical value? So this is the critical value, z star 1.645. So our second step is also done. Now let's move to the third step. Let's see what we have in step number 3. In step 3, let me write here step 3. Step 3. In step 3, we find the margin of error. Find the margin of error. And fortunately, there is a formula for that. What's that formula? E is equal to z star multiplied by sigma divided by the square root of the sample size. Right? So this is the formula. Fortunately, we have the formula, and whenever we have some sort of a formula, it's always a good for us to plug in the values and get the result. Let's plug in the values. Z star is 1.645. I already told you here. And it times sigma, population standard deviation, it's 677. And we divide it by the square root of the sample size. Sample size is 40. Square root of the sample size 40. So if you plug in these values in your calculator and do the computation, the answer comes out to be 176.1. 100, sorry about that, 100. So we have 176.1. I took it a one decimal place. The idea is this, that if we have in our original data there is no decimal place, then my calculation will involve one more decimal place than the original data, right? So that's a rule of the thumb which I usually follow. If my original data has one decimal place, then my computation will contain more than the decimal places which is given in the original data. My original data contain no decimal place, so I plan to take one more decimal place, which is one decimal place in my calculation. So we have found the margin of error. The last step, what we do now? In the last step, we write the confidence interval, the final step, step number 4. In step number 4, what we do, we write the confidence interval. Confidence interval. The confidence interval is, it's always the sample mean plus minus the margin of error. In all these problems, the confidence interval is always written like this. Confidence interval, CI stands for the confidence interval, and it's always the sample mean plus minus the margin of error. Or I can also write it like this. This is x bar, the sample mean, minus the margin of error, comma, the sample mean and plus the margin of error. Okay, so where is the sample mean? Our sample mean is, look at that. The student has a mean annual earning of this one. This is the sample mean, 3120. So let me write the sample mean here. This is 3120 minus 176.1 and 3120 plus 176.1, right? If you do this computation, your answer will come out to be 2943.9 and 3296.1. This is our confidence. This is our confidence interval. So this is our confidence interval, right? This is the confidence interval we're looking for. Now what we're going to do, once we have constructed the confidence interval, it's very important that we interpret this confidence interval correctly. So what is the interpretation? I will show you in the next page also, but let's see on this page. The mean earning of all such students lie within this interval, and we are 90% confident about that. Let's look at once again. We are 90% confident that the mean earning of all such students is in this interval, and we are 90% confident about that, right? So I'm not telling you what is the mean annual earning of the students. I don't know. But what I know, that value is lie in this particular interval. Let's see the next page. So I use Microsoft Excel to show this computation. This is our original data. This is the data, the input we inputted. This is the population standard deviation. This is the sample mean. This is the sample size, and this is the confidence level. This is the intermediate calculation. We have the standard error of the mean, which is given by sigma over the square root of the sample size. This is the critical value, 1.645, and this is the margin of error. We computed the same by hand computation. And this is the interpretation. This is very important that you understand this interpretation. What we are saying, we are 90% confident that the mean earning of all the students is in this interval. So again, I'm not telling you what is the mean earning. What is the mean earning in this situation of all the students? I don't know. But what I know that this earning lie in this particular interval, and we are 90% confident about that. Which means if I construct 100 such intervals, then 90 of them will capture the true population mean, and maybe 10 of them may not be able to capture that particular population mean. That's the meaning of this 90% confidence interval, and this is very important that you interpret this in a very correct way. So let's do the same thing by using another technology called StatCrunch. Let's see StatCrunch. So I already launched a StatCrunch. How you can do the same computation? You go to the stat and go to ZStat. And in ZStat, you go to one sample and he thinks to a few options with data or with summary. We can't do with data because we don't have raw data. We have just the summary data. So we click on with summary. Now this dialog box appears and he's asking for what you want to perform. Do you want to perform a hypothesis test, or do you want to perform confidence interval? We are interested in the confidence interval, and recall that our confidence level is not right now 95%, it's rather a 90%. So you change this value 90% to 0.90, the decimal equivalent. So what we do now, we write the sample mean. It's 3120. Standard deviation, the population standard deviation is 677, and the sample size of 40. And just check this box. If you want a graph for the confidence interval, just have the graph, and now you click. Once you put everything, just hit compute. Once you compute, this is the value you come up with. So look at the lower limit. This is 2943.9. and the upper limit is 3296.1. So this is the same interval. This is the same confidence interval we obtain by hand computation or by Microsoft Excel. Let me show you the graph for the confidence interval. This is the graph, right? It starts from here. This is the lower end point. This is the upper end point, and this is the middle value. This is showing actually the confidence interval. So I hope you understand. Thanks for watching.